Good morning. Excuse the voice, I'm slightly sick, but we'll get through it. Today I'm going to tell you my take on acceptance test-driven development and have a look at both the theory of acceptance test-driven development, why I think it is actually a game changer in agile development practices, and we will be looking at some tools that will make it easier for you. And we'll actually be doing some live coding in the second half. So, how many people are familiar with acceptance test-driven development? If I can see in the light. Oh yeah, a fair few. That's good. How many people practice it and apply it in the projects? A few. Slightly less, but a few. So, yeah, well, that's what we're going to be talking about today. I'm John Smart. I do a lot of work in this area, so a lot of what I'm going to be talking about is based on practical experience, feedback, so what happens on the ground with clients. That's where a lot of the drive for these tools and practices is coming from, and this is where I find it is of huge benefit. So we're going to be looking at an introduction to what I take as ATDD, what I think ATDD is about, how I do it, usually. Nothing revolutionary, fairly standard. We'll see how it works. And we'll have a look at it in practice. So we'll be having a look at some tools that will make things a little bit more interesting. We'll also be taking ATDD a little bit beyond the typical start off with some stories, automate your acceptance criteria and see what reports come out. We're going to be looking at not only going down, but also going up. Seeing how ATDD helps with your requirements, organising your requirements as well. So it's actually something that applies right across the whole spectrum of the development process. Essentially, what's ATDD? So ATDD is example-based development. Yeah? So people are familiar with that general concept? Turns out that examples and concrete cases, concrete examples are a really good way of communicating what you want an application to do. Much more so than more theoretical, abstract specifications. It's much easier to convey what we mean by a story. Which is why lots of ancient traditions and wisdom is passed down from generation to generation in the form of stories, not in the form of 50-page Word documents, strangely enough. So, let's have a look at an example. You notice I'm not starting from an example, actually. It is an example, but I'm not starting from a scenario. I'm starting from a goal. So if you're building an application, hopefully you'll have a goal. It's always nice. And hopefully that goal will be something to do with increasing revenue for your organisation. Usually it should be something to do with increasing revenue, decreasing costs, protecting revenue, or what's the fourth one? They're the three classic ones, and there's a fourth one which is a slight variation on it, which escapes me at the moment. It'll come back to me. If you're a public service organisation, your goals will be slightly different. But it's still ground value. Your goal is actually providing value to the public, so it's not necessarily focused on monetary value, but it's focused on providing some form of value. And today in public service, I think people might agree, there are some fundamental goals around reducing cost. That crops up from time to time. So, when you have an application, when you're building an application, you're going to have a certain number of goals. Again, you notice I'm not starting from the acceptance criteria, I'm starting much further back along. You'll see why. So, your goals, from your goals, you're going to come up with some requirements. Now, what you call those requirements may vary. You can call them capabilities or epics or great big features. You can call them whatever you want, but you're going to have some sort of hierarchy, some sort of structured organization for your requirements. Now, when you do these requirements, always interesting to know if they actually serve some useful purpose. So any features you come up with, you want to be able to map them back to the goal. Because if your feature does not map back to a goal, then why are you implementing it? If your feature does not actually produce value or decrease cost, provide some business value, then there's no real point in implementing it. So your features should always be mapping back to a goal. So starting off with your goals first, and then flushing out the features from the goals is a very effective approach to ensure that you are always building something that actually provides value. So it seems obvious, but it's actually not. You have to put it into a certain context and make it very obvious what you're doing. So this is a process which some people, Chris Matz and some other people in London, have referred to this as a feature injection. Because you're injecting features into your application, and the way you figure out what features you want to inject basically is by figuring out whether they provide value. And you can arbitrate between the value, relative value of different features to know whether it's a good idea to implement them or not. Now, once you've decided on a feature, you can proceed to actually come up defining some user stories. So user stories for me are really a sort of container for examples, for scenarios. So they're sort of more granular features, lower level features. I'm not that hung up on user stories as an artifact. It's more the scenarios I'm interested in and the features you're trying to deliver. So user stories for me are a vehicle for delivering features and a vehicle for organizing scenarios. So nevertheless, user stories, you're going to come up with your cards, stick them on a wall, come up with a backlog, go pick out a few that you want to implement, and lo and behold, you will end up with some acceptance criteria for your user stories. So far, so good, so pretty standard stuff? Yeah? No? Lost anyone? So, you've got your acceptance criteria. Your acceptance criteria are going to be essentially what defines whether your story is done, yeah? So you're essentially defining the criteria that determine when you're finished, when you've delivered, when you can push it into UAT, really. And ideally, you're going to want to automate them. So you'll use something like JBehave or Cucumber or whatever, and put these into the build process so that you can report on them. Now, there's an interesting side effect here when I talk about this to development teams. I like to point out that your acceptance criteria are examples. They're not meant to be exhaustive. They're not meant to cover every nook and cranny and combination of the application's behavior. And the testers will say, yes, but what if I enter a Russian character in that field over there? And I'll say, yeah, well, I don't care. As a business owner, I don't really care. I assume the developers are smart enough to figure that out. And the testers get all offended. And so second time round, I don't say that. I say, okay, well, we'll do some tests just for the testers. So we'll have, sorry about that. We have our acceptance tests on one side, our acceptance criteria, which are a subset of your automated tests, a subset of your requirements, which give you a view of what you're trying to deliver, give you a snapshot of the state of your application, and then you have more focused development tests, development-focused tests, usually implemented by developers, but they will be focusing on they'll be more comprehensive. You get a lot of unit tests here, obviously, but you also get end-to-end, you get integration tests as well, you get functional tests, get more comprehensive tests. The testers will be more interested in the more detailed tests. The BAs, product owners, everyone else basically, are very, very interested in the acceptance criteria, but they don't want to be drowned in the details. So it's important to have that distinction between acceptance criteria automated acceptance criteria and your broader scope of tests. So these acceptance criteria play a very important role in the process, obviously. They define your goals. They define where you're going in an iteration. They make sure everybody understands what you're trying to achieve. So they are very, very much so a communication vehicle. They're a way of extracting information from the BAs, from the product owners, and making sure everyone understands what they're actually trying to achieve and provoking conversations. As a side effect, they help you make sure that you are actually delivering useful, valuable functionality. Just like with TDD, when you're doing TDD, you write a test, and then any code you write must contribute to making that test pass. Take that a level higher, or 10 levels higher, and you get ATDD, you get acceptance test-driven development. Every line of code you write has to be contributing to some sort of acceptance criteria. So any code you write maps back to an acceptance criteria. You're going to go through TDD, you're going to have unit tests and whatnot, but every line of code still will have the ultimate goal of making a particular one or more acceptance criteria work. And anything you add when you implement a particular line of code, you'll have in mind that you're trying to implement a particular acceptance criteria. So you have that context. Furthermore, if you keep in mind what we saw earlier, so your acceptance criteria at one level, but above your acceptance criteria, you have your features, your capabilities, your goals and whatnot. You have a whole lot of context about why you're implementing a particular bit of code. So when you go to implement a user story, you won't just say, okay, we're going to implement full text search. You're going to have the context of why you want to implement full text search, what the business value that we're trying to get out of this feature is, which can give you feedback, give you the elements to provide feedback and say, hey, maybe this wouldn't be the best way of doing it, maybe we could do it this other way. And when you automate them correctly, the acceptance criteria are a really, really nice way of documenting what your system actually does. So this is one of the aspects I really like. I have a mate of mine in Sydney who works for News Corporation on a number of projects, and they have audits from time to time. So they ask, okay, how have you proved that the application does what it says it does and it's been tested and whatnot? And so what he does is zips up the acceptance criteria, the automated acceptance reports, and sends them off to the audit people. Never hears from them again. So it is actually a really good way of documenting not only how you have tested an application, but even more, documenting what the application does. What the application does, what its goals are, and how it actually does it. We'll see in practice, we'll see some reports later on, but it is a really, really nice tool for that. It's the concept of living documentation. It takes a little bit of time to wean people off, especially project managers and BAs to some extent, wean people off the concept of you need to maintain your Word document and you need to update it with every change. But if you do this, use this approach, it can very easily become your definitive source of truth for what the application does and how it does it. And we'll see, you can, if you play your cards right, you'll tie it into whatever you're using for your issue tracking and your requirements management, make it all fit together very nicely. As a result of all of this, you end up delivering faster. Now, it takes a lot, sort of counterintuitive because it does take extra work. It's not like TDD. TDD, I find there's a net gain in the development time when you do TDD. So you spend more time coding, but you end up delivering a lot faster. Acceptance criteria, you do get the impression that you You spend more time writing automated acceptance criteria, takes longer to write the test and maintain the test to some extent, than TDD. That's more work. Nevertheless, based on a few studies I've seen, you end up delivering faster. So I've seen one study, it's to the order of 31% faster delivery with 4 times less bugs when you're using ATDD and TDD. So again, you're going to spend more time, a bit more time on the automated test, and you'll see later, there's a curve, a return on investment with automated acceptance tests. You can write them in a way that makes them very maintainable, and they become very, very quick and quite easy, quite less if you do them properly. But it is still nevertheless work. But because you are producing this documentation of what you're delivering, because you are giving a guiding set of goals of what you're trying to implement, you end up focusing on what you're actually trying to do more precisely. So you write the code that you're meant to deliver as opposed to writing what you think might be useful at some point in time. It's much easier to focus on what you're doing when you have a clear vision of what the goals are and everyone can see them. So even though it does take a bit more time writing the tests and maintaining them, you get that time back, not only in the as far as the quality goes, because you get less bugs, but just because you're writing more focused code. And as a result, reduces risk. You'll see what you're supposed to be delivering up front, everyone's clear about it. Limits the number of surprises, limits the disconnect between what people expect and what people actually get. So that's the study I mentioned. Even taking into account the extra time that automated acceptance tests take to write and maintain, you still get a net quite significant gain in the delivery time, and also you get a huge reduction in bugs. Now the interesting thing with TDD will reduce bugs massively. ATDD also does it. ATDD helps in areas that TDD won't help, typically at the infrastructure level. So you use your ATDD tests, your acceptance tests as smoke tests. So that avoids embarrassing configuration issues when you put the application into production. So you get both you do need your TDD tests, but these ones provide really nice end-to-end tests. So, at the risk of stating the obvious, this process means this impacts the roles of your testers quite massively. You can't do an over-the-wall testing approach with this. You can't build your application, then ask the testers to run through the acceptance tests. You can't do manual automated acceptance test-driven development. It doesn't work. You've got to get the testers involved right at the start. You've got to get them in when you're defining the acceptance criteria and then helping with the automation to some extent. The extent to which they will be involved in automating will depend on your teams, but definitely involved in actually expressing the requirements. So typically when you define your acceptance criteria, you're going to have at least a developer, a tester and a BA together, known as the Three Amigos pattern. You can have the whole team, and the whole team's good, but can cause meetings to drag on and on. So, but if you can get three people, a dev, tester, QA, dev, tester and BA, that's a good compromise. You get points of view, different concerns, enough perspective to make the test relevant and feasible. So testers, the role of testers is massively changed in this approach. The testers also end up not doing a lot of the low-level, mundane, boring tests. They end up doing more interesting stuff like exploratory testing, trying to break the application. So again, testers are often a little bit off-put by this approach. They find some testers find it hard to adapt. It is quite a change in their way of doing things. But it doesn't mean they do less testing. They just do different testing. So, I want to show you a tool called Thucydides. For those of you who are not native English speakers. So Thucydides is a tool, an open source tool, which helps you organize, execute, and report on your acceptance criteria. You use it to document and structure your acceptance criteria. It helps you automate them to some extent. You're going to still use a tool like JBehave or JUnit or EasyB, some sort of more classic BDD tool to actually automate the tests. But Thucydides goes on top of JBehave. In the example we'll be looking at, we'll be using JBehave. Thucydides goes on top of JBehave or JUnit or whatever, watches what's going on when it runs the test, reports on them, and helps you organize the tests. So when you execute the tests, it actually observes what's going on, takes screenshots if they're web tests, and produces structured reports based on what's going on. So notice here I said discover your acceptance criteria. It's diverging a little bit. Discover your acceptance criteria, not specify your acceptance criteria. That's because it is very much a discovery process. So you'll start off with your high-level features. Here we've got a feature, browse catalogue. In order to find items that I would like to buy as a customer, I want to be able to browse through the catalogue. So that's online sales website, what an e-commerce site. So from this feature, we'll come up with some stories. So we'll browse by category. Then we'll come up with some acceptance criteria. Now the thing is, with those acceptance criteria, we're discovering them and discussing them. It's a collaborative process from the story. We pull the acceptance criteria out of the story. It is a very iterative process. Once we have our list of, so here the acceptance criteria are just one-liners. So we want to be able to see all the top-level categories and browse through the category, and we should display the correct products in each category, and so forth. When we go into the details, we'll come up with more precise examples. So typically you might use the given when then structure. So given I want to browse the catalogue when I'm on the home page, and I should see a certain number of catalogue entries that I know should be there. The other approach is the tabular approach, which we'll see shortly. So as I mentioned, you really do want to do this collaboratively. You can't do it in isolation. BAs and testers have very interesting, very complementary roles in this process. So as a developer, you can't do it just as a developer. You do need BAs and testers. Depends on your team, of course. You may be the developer, the BA, and the tester. But typically you need several points of view to get this right. So you'll have the BA coming up with fairly high-level requirements and the tester coming up with details about what needs to be tested. So you get a sort of tension between the BA's point of view, which is high level, the tester's point of view, which is very low level and concrete, and that makes it easier to find this compromise, this sweet spot between the high level requirements and the actual concrete test, which will contain too much detail. Because your acceptance tests are high level. Your acceptance tests are not down in the nitty-gritty detail, as we'll see. So here, once we come up with this given when then, we're going to transform it into an executable form. So here we've got this as JBehave. Cucumber would be very similar in order to blah, blah, blah. So I won't bore you with the details, but we've got a narrative section at the top where we just give the context of this story, and then we have the given when then. So that's an executable requirement. When we run that, it will be reported as a pending test. So I have this requirement which is pending. That's the orange up there means pending. Then you go and implement it. So as I said in the examples, we'll be looking at JBehave. I do this quite often with JUnit as well. JBehave I find gives a little bit more detail with a little bit more expressiveness at the top level. So you get this given when then, whereas in JUnit you just have one test method with all of those. So it's a little bit harder to make the structure obvious. So this is how we'd implement them. Now, you'll notice here we're not going and talking about any details. It's very, very high level. So the customer opens a home page. That's about as close as we get to a UI. Customer should see a set of categories. So I'll show you this code in action later on. The next level of detail down. So we start off with a very high level. Your JBehave or your very top level tests should be really, really high level, very simple. Typically you're not going to have much more than 7 lines. 1 line in this case per method. You get really 1 or 2 lines per method in each given when then method. You get very high level, very succinct. Should read like a story. Shouldn't focus on the details too much. The details come later on. The details come here in the steps. So here we've got an opens home page. Here are the steps. We're using our page object. So if you've done any automated web testing, you'll be familiar with the page object model. So here we've got a page object for our home page. So we open the home page, then we're going to go through and check that the categories are all displayed. So we're basically getting the categories from the home page and checking that everything's there. So these steps focus on the business logic, asserting the business logic. The page objects worry about the details of the implementation of the Webdriver stuff. So as I say, you can also do this in JUnit. So this is what the JUnit would look like. It's quite frequent to see this in JUnit. The big difference, I'd say, is that here you don't have the given when then spelt out. You have a method for each. You have the same approach. It's just that it's a little less obvious where what the structure is. So it's a little less obvious what you're trying to achieve in a test. When you execute your tests, you'll come up with a report. So the report will have certain tests pending, certain tests passing. So as you implement a test, hopefully it will go from pending to passing. You get this concept of how much of a capability has been done based on the number of features that you've actually delivered. And also, so here you'll notice it's not a round figure because in this case it's using a weighted calculation based on the size of each feature and the size of each acceptance criteria. So the more complex an acceptance criteria is, the harder it is considered to develop. So it's a metric, rule of thumb metric, which seems to give reasonable results. So here's another interesting aspect of it, which you don't see in pure JBehave or EasyB or Cucumber or any reports of that nature. Now remember, we are talking about having our capabilities, our features, our stories, our scenarios. You want that hierarchy to be reflected in your reports. So you want to be able to see how many features have actually been delivered for a particular capability. And also how many have been specified but haven't got any tests. So this is not a test report, this is a requirements coverage report. So we've got here a capability up here, the first one. In order to earn money by selling things, we've got 0 coverage, nothing's been done. So there may be tests that are pending, or there may be no tests at all. So we're dissociating the concept of the structure of your requirements in other words, your story cards, and everything that goes before them, and the tests that test them, the tests that have actually been implemented. So this gives a much more concise view of what's really been done. You don't actually have to have an implemented test for it to figure in the reports. When you get down to the story level, so here we've got a story. So we say what the story does, so we give the context, then we got our acceptance criteria, go into an acceptance criteria, and here we're looking at the other end of the scale. We're going into the details. So we've got the what does the story, what is the story trying to achieve, and what does the acceptance criteria, what's its role in life, what's it trying to do? So as a buyer, I want to be able to list all the ads with a particular keyword. And so here we have a full example, or basically a worked example of how you demonstrate that that works. So each step is recorded, including the parameters. So if you've got data-driven tests, you'll see all the data, the properties going into it. And if you've got a web test, then it will record the screenshots. So give you a sequence of screenshots so you know exactly what's being recorded. So this is where the living documentation comes into play. So you've got a record of for each feature, for each requirement, you've got the record of how it's actually been implemented. So these details may change or not. It will usually change if there's a significant change in the workflow, in the process. But it's actually relatively stable. If you keep the levels of abstraction defined the way we do here, it's relatively stable. Details of the screen will definitely change as things evolve. So screenshots will evolve. But at any point in time, if someone wants to know how searching by keyword works, you can go in here and have a look at the screenshots, have a look at the steps, and see a worked example of what it's supposed to do, plus the context, what you're trying to achieve with the narrative text. So this is where the concept of what I call functional test coverage comes into play. So normal test coverage is how much of your code has been exercised when you run a set of tests. What I call functional test coverage is the concept that if you have a set of requirements, you consider them done when the acceptance criteria pass. If there are no acceptance criteria for a requirement, obviously there's nothing to prove that the feature's been implemented, so it's considered not done. So we can distinguish broken tests, if it's been implemented but it fails, tests that are working, you've got acceptance criteria and they work, and requirements that have been specified, but maybe you got acceptance criteria, but they're pending, so it's in progress. Maybe you got no implemented acceptance criteria at all. You've just got the requirement that you need to deliver. So this is a really nice way of illustrating progress. To actually see what's been done in terms of what acceptance criteria have been implemented versus what requirements have been specified in your story cards. And you can do it at different levels. So remember, again, I was talking about capabilities, features, stories, tests. Look at the capabilities. You can see here, we've got to build a wish list capability. I've done sod all there. Nothing's been done at all. Catalog, yeah, it's sort of 88.6% finished. Actually, that's just a relative number based on the size of the steps, so it's to be taken with a grain of salt. But what it means is that there's still work in progress in the capability function. You're selling products online, that looks pretty much done. At least we've got one feature with a test. Well, normally, obviously, you'd have more than that, probably. But this is a very high-level view. This might be a really big application. That's obviously just a toy application, but typically you have 50, 100, 200 acceptance criteria, automated, and you might bring it down to half a dozen capabilities that you're working on. So then you can drill down into features, into stories and so forth, and then find out what the tests were for a particular story. So that's one of the things that I find really useful in this approach is the way you organise these requirements from the capabilities right down to the acceptance criteria and how you can report on those. This is for BAs and project managers and non-technical people. They really like this approach. Now the thing is, that requires a bit of discipline because you do have to actually organise your requirements in a certain way. So often what happens if you've got a whole set of JBehave stories, you might have a big directory full of .story files, same with Cucumber or whatnot, and that just gets a huge list of acceptance criteria without any structure. So to make this approach effective, you need to be able to tie in your acceptance criteria with the requirements and the hierarchy in your requirements. So a very simple approach, which you can do with Thucydides just out of the box, is you just use a file structure. So here we have a file structure with capabilities, features, and then stories, and that will deliver out the structure we saw earlier on. And that's what gives us this nice visibility on what's been delivered, what's been done, and what's still work in progress. So the other trick here is that you have these narrative.txt files which actually contain the context of a particular capability, given or in order to, as a I want structure for a capability or a feature. And that gets included in the reports. And that's really important because that gives you your context for a feature, for a capability, for a story. Gives you the information about why you're trying to deliver this. It's really important for the documentation side of things. Now in practice, this works for small applications, but in an enterprise context, you'll probably hook this into your whatever tool you happen to be using to manage your requirements. So obviously there are quite a few. And Thucydides doesn't really care. What Thucydides does is gives you an interface that you can put on the class path to talk to your whatever tool you're using. So I've done this with Jira quite a lot because in Sydney we use Jira a lot. So here's an example using Jira. So in our story we've got this issue tag. The issue tag goes into a custom class which implements an interface, sits in the class path. Thucydides goes, hey, I found a requirements provider. Let's see what requirements go with this story. So it'll go and find the card, work its way up the structure, and come up with a report with our capabilities, features, and whatnot. So that works really nicely for when you got custom Jira requirements structures, as you will. And so you can use exactly the same approach for Rally or whatever requirements management system you happen to be using. That makes BAs really happy because that means it fits in with their favourite tools as well. So that's one aspect of requirements. The other aspect of requirements is sometimes you have orthogonal concerns. Sometimes you have things like non-functional requirements. You might want to document certain components. You might want to say, okay, this is being done in this iteration. So we want to just report on the current iteration. You might want to distinguish between your acceptance criteria and the more general, broader tests. So there are quite a lot of different ways you might want to slice and dice your tests. So we do that with tags. So here we've got a JUnit test. So we've got this tag annotation where you can just add arbitrary tags. And same thing in JBehave. You can define arbitrary tags in your requirements, and then they will appear in the report. So you can then click on a particular tag and see what the acceptance criteria associated with that tag are, so what the features and stories and so forth associated with that tag are. This is, for example, if you're working in iterations, you might put a tag for the current iteration and then distinguish between the current iteration and everything else, which are basically regression tests. That way you can have a better idea of the progress of the requirements that you're working on in a particular iteration and not have them grouped in together with all the existing ones. It makes it a little bit clearer what's going on. So that's for the requirements side of things. That's coming up from your capabilities and so forth, down to your stories. The next thing that Thucydides helps with is helping you structure your tests. So if you've ever looked for Webdriver tutorials, you inevitably get something that looks like this. So you get your lovely acceptance criteria, and the way it works is you dive straight into divs and links and selectors. You go straight into the detail with your acceptance criteria from the word go, basically. The problem with this is it becomes very hard to maintain after a while. It sort of crumbles and collapses after a few months. It becomes hard to maintain because you get this massive duplication. So that's why people have come up with this page objects pattern, which Webdriver implements very nicely. We're using a page objects approach. You'll have a class which encapsulates a web page and presents an API that you can use to talk to that web page. This should be, I imagine, everyone's familiar with the page object. Who is not familiar with page objects? Wow. Okay, so page objects are a way of writing an API for your UI, an API for your user interface. Back a slide. Don't do this. Just emphasizing. Repeat, don't do this. If you see an acceptance criteria with references to HTML elements, either rewrite it all or run away screaming. Your choice. Page objects are a first level of abstraction. The nice thing about page objects is it means that you can encapsulate all of the changes that are going to happen to a particular page in one place. So if you rehash a whole web page, if you don't change the fundamental behavior, then you'll have the API that remains the same. The HTML interactions will change, but the API will remain the same. And so the rest of your test will not be affected. If you change the behavior of your page, then sure, you'll change the API, but you're still going to limit the impact of changes. So here we've got an example, the home page. So we open the home page, we select a category, then we select some subcategories, and we expect that we should have a product with a particular title. This is the application we'll see later on. And so in Webdriver, you're going to have this is a Thucydides Webdriver page object. So it might look something like this. So what's happening here is that your page object is, so we've got a find by, so this is a CSS selector, then by a link text. So we're looking for a link with whatever the category that we're looking for is in a link inside this side category list classic component somewhere on the page. Then we're going to click on it. So the point of this approach is that you hide the details away inside the page object. Makes it much, much easier to maintain. Makes the tests a lot clearer. Tests a lot easier to understand because you're talking in terms of semantics, not in terms of details about how to interact with HTML pages. The only disadvantage I found with this approach is that for acceptance tests, except if you're doing toy ones, acceptance tests tend to be complicated beasts, so they tend to have a lot of business concepts mixed in there. Page objects are actually still quite low level from the terms of acceptance tests. So if you're working with an acceptance test, you still want a little bit of a higher level of abstraction. It's not quite the level of abstraction you want. You don't want to talk about interacting with pages at the top level of your acceptance test. At the acceptance test level, you're really talking about what you want to achieve in terms of business goals. You're not even interested in pages yet. So pages are great for encapsulating the HTML details and making the tests easier to maintain, but they're still not quite there for the level of abstraction we want. So this is where Thucydides, and JBehave to some extent as well, introduces the concept of steps. So JBehave has your given, when, then steps. Here we've got steps that can be nested inside steps. So I've got here as a JUnit version. So rather than what we had before, so home page, open, select, blah, blah, blah. So you're saying select top level category, select subcategory, select subcategory. What we do if we're doing it with steps, we do something like this. So open home page, browses product categories through this list of product categories, and then should see product with title, blah. So here we're really focusing on what we're trying to achieve and what we're trying to do in business terms. So about the most technical element here is the actual opens the home page. From a business, but then browses product category, we're not really talking about where you click, is it a drop down or a link or a JavaScript component or jQuery, or we don't really care. We know we want to browse through the product category, which is a business concept, and then we should see a certain product with a particular title. And then the step implementation, so we got these step annotations in our methods. This is where we talk about how we actually do this stuff. So browsers product category. What do we do here? Well, first of all, we select the top level category. Then for each of the subcategories, we go through and select browse through category, subcategory. So you notice we've got a step that calls another step. And in this sub-step, we just say select subcategory on the page object. So the step library talks to page objects. But the test itself back a bit. Here we go. So the test itself doesn't talk to page objects. The test itself expresses things in terms of business goals, and then the step worries about how you actually interact with the pages to do that. So the steps talking to page objects, which hide away the HTML details, and the steps themselves hide away the how of the test, so that the test itself can focus on the what. So what are these test step things? Well, they're just ordinary methods. So pretty much all these examples are in Groovy, because that's what I tend to use for this sort of stuff, but works fine in Java. Excuse me. So a step is just an ordinary method. You can have parameters, and the parameters get recorded and reported. So that makes it quite nice for the reuse side of things. You can also mark them as pending, so you can define what you're trying to do. Say, okay, we need to search for something using some search terms. No idea how we do that, but we need to do it. So you write a pending test step. The test will report it as pending, and in your reports, and you can go and make it work later on at your leisure. And you can also customize the title. So by default, it will take the title. So I tend to be a little bit cavalier, I'm afraid, with the Java naming conventions when I write tests. So I tend to put underscores in the test step method names. Sorry. But either way, if you are underscores or camel case, in the reports, it will go and take these and convert them into an English sentence. If the English sentence, so here we've got, should see a number of visible ads in the carousel 1. Oh, I'm finicky. I think that sort of poor way of reading. So I'd rather read like the step the carousel should display 1 at a time or 4 at a time or whatever. So you can annotate the step annotation. You can configure the step annotation so that it reports the parameter in the way that you like. It's all about making the reporting clear. It's all about reporting, getting the information you want out into the reports. So with complicated business logic, it's quite frequent that you have steps that call other steps. There's a lot of reuse in steps. Steps are all about reusability. Now, when you're writing all of this sort of automated acceptance test, as much or even more so than unit tests, you should really treat this stuff as production code. So you take all the care with the acceptance criteria as you would with your production code. So you refactor it, you try and make it as reusable as possible. You try to do everything that you would to make it clear and readable and reusable that you would with your production code. So if you don't tolerate duplication in your production code, you wouldn't tolerate it in your acceptance criteria either. If you follow the basic principles that you apply to production code, it will make your acceptance criteria a lot more maintainable. So when you run these reports, run these tests, it will generate the reports. So you get this high-level opens homepage, browse product, and so forth. In the reports, we got to open homepage, browse products, and then how does that work in the details? Oh, we select the top category, then we browse through the subcategories, and we should see the product, whatever. So here, you can see how the steps are simply reported in the test result with a little bit of tidying up and Englishification. I doubt that's a word. Anyway, prettying up. And so the point of this slide is basically to emphasize that when you're writing your test steps, you want to express it in a way that so that it will come out as living documentation in your reports. So summing up on test steps, we're trying to dissociate what a test does with how it does it. So at 2 levels. What do we do at a business requirement level? How do we do it in test steps? And then inside the test steps, what are we doing? And then how we do it within the page objects. So you typically have at least 3 layers. You've got your test, where you define your high-level business goals. The steps, where you say how you're going to achieve those business goals, but in relatively high-level terms. And then the page objects, which actually interact with your HTML page. Thucydides doesn't have to be used with web tests. You can use it with any sort of test. So same principle would apply for non-web acceptance tests. You still have multiple layers and whatnot. And you'd still get the same reporting, except you don't get any screenshots. So when you're using JBehave, this gets even nicer, because in the JBehave you have what are effectively steps as well, very high-level steps with given, when, then. So here we've just got exactly the same steps class that we had earlier on, scattered through the given, when, then, instead of in one method. And you also get this narrative at the top, or you optionally can. I always like to put it in there because it gives a nice set of context. And so the implementation looks very similar, except that it's split out into steps. And when you run the reports, you get the JBehave narrative up here. Then you have the what and the how, as we saw earlier on. So tools like JBehave integrate really nicely with this sort of approach. So advantages of using JBehave in this context. I don't use JBehave for all projects. JBehave is really good for living documentation. It is very good when you're doing an end-to-end approach. So proper ATDD, where you're working with the BAs and the testers from the word go, and you're taking it all the way through the process. And some projects I work on, they call me in a bit late in the piece, and it's basically retrofitting acceptance criteria. In that case, I'll just use JUnit because I don't want the overhead of maintaining the story files. So maintaining the story files is a bit of extra work. It's worth it if when you get that nice documentation and you're working with the requirements all the way through. If you're not working with the requirements, if you're just retrofitting acceptance tests, regression tests effectively, then you can do it with JUnit and get a lot of the benefits with a little less maintenance. So it really is choosing the right tool for the job. So Thucydides also offers some nice features with your page object. So we saw earlier what a page object looks like in Thucydides. So here I just want to show some of the cool features. So this is an area where there's a lot of active development going on. So we're working with some of the JBoss folk to integrate Archillion and some of their Webdriver features as well. So there's a lot of activity going on in this area. So out of the box, Thucydides just provides a lot of utility functions that make it easier to write page objects. So things like fluent selectors. So with Webdriver, a Webdriver page object has these find by annotations. If you're going to use something on the page multiple times, you typically use a find by annotation because you don't want to repeat yourself. So here we've got find by CSS and give a bit of CSS, and that's how we find the search button. For other situations, you may be looking for something specific in a page in a particular context, or it may be dynamic. So when we choose the category, we're going to look for the category select ID, probably a div or something. And then we go and look for something with an arrow, and then we click on whatever happened to be under the arrow. And then we're going to find the category select div. Then we're going to look for something with a link text. So that by is just standard Webdriver stuff, by link text, by partial link text, by CSS selector, do a lot by XPath, and then we click. So the point of doing this is that it's easier to read than one humongous XPath expression, which is what you'd have to do otherwise. And if it's easy to read, it's easy to maintain. There's also a shortcut. You can use the $sign rather than find by if you just after the element. So you could use search term directly. Say search term send keys. Thucydides can take screenshots, basically a blow-by-blow account of what your application is doing. If you put the $sign or the element method, which is the same thing, it will, if you're typing in, it will go, hey, there's something happening on the UI, I'll take a screenshot of that, thank you very much. And so it will take a screenshot of actions going on during the test. So you get a sequence of screenshots showing the fields being filled out and whatnot. The other point of doing this is that it does things like clear the text box if it needs clearing, make sure that it's actually enabled so you get a bit of Ajax support. A little bit of tidying up and bookkeeping, stuff that you'd normally do yourself, but just makes it a little bit easier. So one important thing that you need to know about page objects. Page objects, like I said, are APIs for your user interface. They encapsulate the logic, the HTML logic inside your page, and they present an API which should be in terms of POJOs, typically. So here, for example, we've got this POJO class called cart item, which has just got a few strings and doubles and stuff. And so when we call get cart items, it will go through, build up a set of cart items from the web elements. So what's it doing here? Cart item containing quality, products called product. So the interesting bit here is this. So we've got product name, price of item price element, price of total price element. And those methods go and look up a web element inside the cart item. So step back a bit. Here we have a list of web elements. So that, the shopping cart items, is a list of web elements. So a shopping cart is basically, in this application, it's a table. I think it's a table with a set of rows, I think, from memory. Should be able to see that. Yes, it is a table from a set of rows. So each row is an entry in the shopping cart. So when you use this shopping cart items, Webdriver returns a list of web elements where each web element corresponds to a TR. So here in this method, the get cart items, we're going to iterate over the list of shopping cart TRs, and for each TR we're going to try and extract a cart item POJO. So the interesting thing here is we're doing it at the level of the web element, not at the page. So all of this stuff is working with a web element. So it's local. So each row will have a different product title, a different price, and so forth. So here, these methods, I've just split them out into methods to make the code a bit more readable. Here we've got this web element, which is the HTML row. So we say find element by class name and then get the text. So that is just classic Webdriver stuff. With Thucydides, you can make it a little bit more fluent. So rather than saying so before it was cart item find element by class name. With Thucydides, you can do a bit of a shortcut. You say element cart item find by, so you give it a CSS selector or an XPath expression, and it will go and look up the CSS selector or XPath expression within that element. Or if you can't be bothered writing element, then you just use $ and it'll do the same thing. So you can do the same thing as in Webdriver, it's just a little bit more concise. And obviously that works in Java as well. It's probably not obvious. It works in Java as well. Even the $ thingy. So here's a last example of the selectors. You can also get a list of web elements as opposed to a simple web element. So here we've got find all, and giving it a CSS selector, it will return a list of, so what are we doing? We've got a graph and we're going to try and get the y-axis. Is that it? Yep, the y-axis from that graph. So again, you can do that in Webdriver. It's just a little bit more concise with the Thucydides layer on top. So helper methods, really. So this, following example, we're going to have a look at the Maven Central Repository Search feature. So when anyone use Maven, you may have come across this site. It's a very useful site. Type in the name of an artifact, it will list all the artifacts with the latest versions and whatnot. That's not why I wanted to show you this example. I wanted to show you this example because, well, question first, who works with applications that use tables of some kind, HTML tables? No one at all. Yes, most of you. Yes, HTML tables are quite frequent, and there are times it can be very useful to do stuff with them. So Thucydides has, and they're a bit of a pain to use, so Thucydides has a couple of shortcuts to make it easier to work with HTML elements. Here we've got an example. So we're testing this, the Maven search page, should search for artifacts by name, so it opens a search page, searches for Thucydides, should see artifacts where the artifact ID is Thucydides, the group ID is net.thucydides. So you notice we've got this, the static method. That's where the magic happens. The rest of the is a hum crest search. So you can build up structures like that and then use this should match method. So should match to the search results, returns a set of POJOs, and the matches are the ones we passed in. So it will check that the contents of this page matches the criteria that we defined here. Let's have a look at how that works. So here we've got artifact as a POJO. This get results just returns a list of POJOs. So it returns the contents of the table in HTML, the HTML table as a list of POJOs, and then matches the contents of those values against the POJOs. So you can use any Humcrest matches here. So this actually comes in quite useful whenever you've got tabular data. Whenever you're working with list of results and things and you want to make assertions about the contents of those results, this can come in quite handy. There's also a way of working directly with tables. So here we have a results table. There's a method called rows from, which returns the contents of that table as a map. So it looks at the headers, uses the headers of the table, or the first row if there isn't a header, as the index of the map, and then puts values for each row. And if you do that, you can do exactly the same thing. So it's the equivalent of returning POJOs. So you can make asserts along these lines, as we saw earlier on. So the nice thing about this is that you can do a lot of testing for relatively little effort. So if you've got any constructs like that in your applications, this just makes it a bit easier. You can also use this filter rows method, which uses a similar approach, but it's usually used at a lower level because you're going to be doing things like manipulating the row itself, clicking on it, stuff like that. So here, filter rows returns a list of web elements that match the criteria that you pass in. So we'll say something like, click on first row matching matches, and then the matches can be whatever we defined up here. Are we going for time? Okay, so a few more things I want to take you through before we have a break, and then we'll start on with some real live coding examples. Fluid weights. So fluent weights are convenience methods, effectively. These actually predate the Webdriver weight API, and when that came out, they were refitted to extend them. So when you're doing any Ajax applications, you often need to wait for something or other, wait for text to appear on the screen, wait for components to appear, wait for things to disappear. So there are a lot of built-in functions in Thucydides that let you do that. So things like wait for text to appear, add it to your card, just hang around and wait for that to appear on the screen. Or you might want to wait for something to be present on the screen. It's not a particular text, it's just something that you know will be there eventually. So here we're uploading an image, it does its funky uploading stuff, and then when it's done, this something with a photo class will be on the page, so we just wait for it to be rendered. Or you can do things like that. Wait for a certain number of milliseconds. Don't advise doing this very often, but you can do it if you want. Or wait for the absence of something. So often you get those little loader thingies, hourglasses or whatever. In this application, when I looked at the HTML, it had an ID of loading. So to wait for the page to actually finish, an Ajax page to load, it doesn't really load. All it does is hangs around with this little load graphic on the screen, and when it disappears, you know you're good. So you do wait for absence of and then loading, it will hang around. So it waits for half a second until the loading actually starts, and it waits for the loading icon to disappear. You can also do things like wait for XPath expressions, excuse me, or you can write your own custom waiter. So this is a thin layer on top of the Webdriver API. So wait for a condition until, and here we're returning a Webdriver method. The essential bit of this in a nutshell is this line. So we're checking that state as the current selected state, whatever that means. So we're going to wait for this to happen. So that's trying to do functional programming in Java. In Java, pre-Java 8, obviously. Works. You can, at this level, it still remains quite readable. You can also, while you're at it, check that things are visible, invisible, and so forth. So here we're saying should be currently visible. So if it's not visible, it will throw an assert. If you just say should be visible, it will wait round and hang around a bit if it's not visible and time out. If you say should be currently visible, it will check right now and not wait at all. So it's a way of speeding up your test if you know that it should be there at that point in time. Same thing for enabled, should be currently enabled. So all these methods, they're really helper functions. You can do most of this stuff with pure Webdriver. It just makes the test a little bit more concise and therefore a little bit easier to use. So you basically pick and choose, use whatever you think is useful to make the test easier to maintain. Last thing I want to look at before we have a short break is just a few tips on working with Webdriver. First tip is, wherever possible, use CSS. XPath is hard to read and hard to maintain. It is also hideously slow on Internet Explorer. Now, my solution to that is not to use Internet Explorer, but I'm told some people don't have the choice. So. Seriously, XPath is, sometimes there are times when you have to use it, but if you can avoid it, CSS will be built into the browser, so it'll be a lot faster. A corollary of that is that if you're working, so here's why I don't like XPath too much. You tend to get into things like that. The XPath expressions tend to be hard to read, hard to test. It's usually a lot easier just to look for something, then look inside that something, just drill down until you get what you're looking for. So that tends to be more obvious what's going on, and so it's easier to update, because you got to. This is all about maintenance, making the code easy to maintain. As I mentioned, very important rule: Webdriver elements should not get out of your page objects. So there should be a watertight barrier between your page objects and the rest of the application, and anything to do with Webdriver should not go beyond the page objects. And I actually applied the same rule at another level. Page objects should not appear at the top level tests. So I maintained 3 distinct layers, but the page object layer is very important. So your page object effectively is an API. So here we've got an API, the one we saw earlier. You'll get cart items, which returns a list of pojos, and then all the details inside. So the point of a page object is not to return web elements, it's to return pojos that you can then manipulate in business terms. The last thing is, think of a WebDriver query, any interaction with a web page, as the same as a JDBC query, except you can't do selects with returning too many, you can't do joins and stuff. But in terms of performance, if you have 100 interactions with a web page, you've got to be careful of how long that's going to take to run. So if your tests are slow, you might want to look at how much you're interacting with the web page. If you've got a table and you're reading every cell in the table, that may slow you down. If you're doing it with XPath on IE, it can take minutes and minutes. So you do want to be a little bit careful of that. So think about when you're figuring out how you want to implement a particular test, what you want to interact with. Be mindful of that. So if you want to learn more about this stuff, a site called Thucydides.info, which is where all the documentation and whatnot lives for Thucydides. You can also find it's on GitHub. And there's the Thucydides webtest.com, which contains articles and tutorials and announcements and whatnot. So this is not the end. We'll have a short break because I'm told it's good to let people have breaks, otherwise they get sick of me talking. We'll have a 10-minute break, and then I'm going to do some live coding. So I'll show you a real application with, well, an application. It's a demo application, but it's real enough, where we've got Webdriver, page objects, steps, JBehave stories, the whole stack, right from the requirements down to the page objects. And I will show you how to implement a few acceptance criteria using Webdriver, give you a feel of what's involved in actually implementing these tests, and how the maintenance, how you can write them in such a way that makes the maintenance a bit easier. So I propose we reconvene in 10 minutes, and then I'll take you through that. Thank you.